My name is Dimitri, and in this video of my K3S Build Series, we'll dive deeper into setting up a cloud-agnostic project structure and provisioning infrastructure in the Hetzner Cloud. Yes, we will get our hands dirty by writing Terragrunt and Terraform code. Whether you're deploying on AWS, Hetzner Cloud, or on-premises environments, this project setup gives you a maintainable and clean way for further automations with Kubernetes and GitOps. Here's what we cover in the episode: the project structure, the environment, the state, the modules, execution scripts. We will develop the Hetzner Cloud infrastructure module, which contains all the subnet, networking, and SSH setup, and also the firewall rules. We will deploy the server and the worker node in the Hetzner Cloud. We will have a live debugging because nothing works at the first time. And then we will recap what we've done. If this content helps you or inspires new ideas, then don't forget to like, subscribe the channel, and hit the bell button to stay updated as the series continues. I'd also love to hear your thoughts. What do you think about the style of this video? Should I go deeper into code, into the tech stuff, or keep it at a higher level? Your feedback helps me to improve. Okay, let's dive into it. Project structure. Okay, let's start with creating the project structure. I've opened Visual Code Studio here, and for the project structure first we need our environments folder, which we'll just create. Then we need a execution folder, which will contain our scripts. Then we will create a modules directory for our Terraform modules. And of course, we need a state directory, which will contain the state of each module. We need to create a root.hcl file, which will contain a global configuration for our project. Let's do this. Okay, and in the root.hcl file, we will define some locals. First, the env name, which will be the directory name. Path relative to include, which will be our development environment, like dev here. Then we will fetch the module name, for example, infrastructure. And then we will define the global state directory. We reference the local env name here. And then we will also include the module name we fetched earlier in the step. And then just tf state ending. Okay, that's it for the locals. Then we will define a remote state. The state will be a local state. So our backend is a local. And the config for it. Normally you could define the provider config here for the remote state, like AWS S3 bucket, but we will just provide a path, state path here, which we defined earlier. And that's it for the root.hcl configuration for our project. Really simple. And let's do the next step. We will create a new file, apply dev, which will be a bash script. And here we specify the Terragrunt download directory, where all the Terraform modules downloaded from a Terraform repository are stored. Terragrunt cache, and then the command we want to execute. It should bootstrap the backend, so actually create the state folder, and the working directory will be envs dev for the dev environment, which we created here. Now what we need to do is go into our environments folder. We have the dev environment here, and we create a new file, which will be named env.hcl, which will contain our environment configuration here. And the environment configuration we need, for now, it's just a simple structure. Let's start with the locals. The variables we will use further in our configuration of the environment. Stage dev and root 53 zone in case you want to use root 53 service from AWS. It's a zone name I have in my AWS account, which I use to provision some records. And then we have the inputs. For now, let's just keep it with the stage. So stage. And here, after we have created our first module, we will define our infrastructure configuration here. So that's it with the project structure. For the next step, we will create the modules. Hetzner Cloud Infrastructure Module. Here we have a typo. We will reference the envs directory, and now we can proceed with creating the first module. Okay, the module for our infrastructure in the Hetzner Cloud. For this, we will create a directory in the modules directory. I like to name the directories and the files with numeric index to keep everything ordered. And for the first module, we need a variables file. And the variables are actually the input for our module, and the output will be the output mechanism of Terraform. So let's start with the input for this module. And for the first variable, we need the stage. Then we will need the Hetzner API token, which will give us access to the Hetzner Cloud to provision the infrastructure. Then we need the number of the server nodes, which will be provisioned. And we also need the number of worker nodes. Then we also need the type, the instance type for the worker and server nodes. Then we want to define the first data center and the second data center, because we want to spread our infrastructure over multiple data centers. And we need the zone we provision our infrastructure in. And then we will have a variable which is there to control whether we want to expose the management ports like the Kubernetes API port and the SSH port to configure our server and worker nodes and set up the K3S cluster. And then we will provide our SSH public keys to access the nodes through SSH. Okay, these are the variables we need, and then we'll proceed with the network. For this, we will create a new file. The first resource we need in our network implementation is a hcloud network resource, which will define our private network. For this, I will use a snippet from the official documentation of the Terraform provider for the Hetzner Cloud. And the name we want here is our stage-network. So we will have a separate network for each stage, and the IP range will be 10.0.0/16. Okay, the next resource we need is the subnet. We will define a subnet within this network, and for this I will use the snippet here. This defines the hcloud network subnet, which requires the network ID, and I will specify the network ID of the private network we configured earlier. And the type will be cloud, yes. The zone, we have our variables here, and we defined a zone variable called the hcloud zone. So we will just use that instead of a hard-coded value. And the IP range, and we will define a dependency for the network to be sure that everything is provisioned accordingly. Now we need some firewall configurations. For this we will use the firewall resource here and call it firewall egress TCP any, the outbound connection to the internet. And then the name will also contain the stage here, egress TCP any will be the name. And the only rule we need here will be direction out, and the protocol will be TCP, which will allow outbound access to the internet. But instead of the source IPs, we need the destination IPs. Okay. That's the first firewall rule. We will define more firewall rules. So then we will define a firewall rule which allows the internal communication for UDP and TCP within our network. and call it internal TCP UDP allow all. The name will also include the stage. And the rule we need here is an outbound rule. The destination IPs we will specify by using the IP range here. Maybe we want later just allow the internal communication but exclude the outbound communication to the internet. That's why we have two separate rules here, but of course this rule includes this rule because it's much wider. Okay, then we need another rule which will allow the communication in from the same IP range for TCP, and instead of this destination IPs we need the source IPs here. So now we have two rules for TCP. Now we have to specify the same rules for UDP. Okay, done that. The next firewall rule we will need is the rule for incoming connections. We will need an inbound rule, so we just take this one and modify it. The source IPs will include all IPs for 22. Okay, that looks fine. Then we need a firewall rule for the inbound HTTPS traffic, and here the port differs, 443. The source IPs are the same, and we want to specify the firewall rule for the connection through the Kubernetes API. For this we will specify the port 6443, and it's the ingress API rule. Okay, we have the required rules configured now. Okay, let's continue with defining the infrastructure component for the server. First, let's fix this FUNet here. That's the subnet 1. And then continue creating the resource for the server. I will use the snippet from the official Terraform documentation for the Hetzner Cloud provider. And now we will customize it. We want to specify the count of our server node from the variable. The name will of course include the stage. Then we specify the image to Rocky Linux version 9. The server type we will also provide through a variable. The data center, it's a little bit sophisticated because I want to spread the infrastructure over multiple data centers. That's why I use the count index here, and whether it's even or odd, I take the first or the second data center. We don't need labels here. Actually, it makes sense for a production environment to tag and label everything so you can then analyze the cloud costs, but we'll keep simple here. We want IP enabled. We don't need IP version 6 here for the public connection, and then we specify the network. We'll keep it simple here and just use the index to specify the internal IP, starting with 4 or SSH keys for the configuration of the nodes. For now we have no auto-completion. That's because we have not configured the provider yet. We will do this now. You can just go to the official documentation page and copy it from the Use Provider button. For the provider we also need the token. Okay, now it says we don't have a declaration. Let's check that. Actually it's a list of strings. That's why we get an error. Now we have it right. Okay, continue with the configuration of the server. For the firewall IDs, if we have the management protocols exposed, then we will use this firewall rules. We have the egress here, we have the internal stuff, then we have the ingress for the SSH and the Kubernetes API ingress firewall rule. And if we don't have it, we will just stick with the egress and the internal traffic. What will be executed when the server is provisioned? For that we can define a user data file, which will be a simple bash script. We will create that, and it will just contain a yum update. So we have all the packages and repositories updated too. Okay, now we'll name our server and continue with the worker nodes. For this, I'll just copy the content of the server file and just replace the string server with worker. And of course we don't have a resource called hcloud worker. Attribute server type. Okay. Now we have the resource configured correctly. And the internal IP will start from 104 for the worker node. And the user data will be the same. The firewall ID is the same. Okay. Now we can proceed with the SSH keys. For this we will create a new file, ssh.tf, and define the hcloud SSH key resource. We will iterate for loop. So we will use the index and the key. Then we have the name. Now to the configuration of the state file. Since the state is managed completely by Terragrunt, we can just reference that we have a local backend here with no configuration. That's it. So we have the variables defined here. We have the network defined. Then we defined the server. We defined the worker. We have our SSH keys. We have defined the provider. It's the Hetzner Cloud. And we defined the state for the module. We have our user data. And also we need a Terragrunt file to pick everything up by Terragrunt. For this we create a Terragrunt.hcl file, and this will just include the whole folder here. So all files will be included. Also we need to define the output. For this we will create an output file. Our output will consist of server IPs and the worker IPs, and also the internal IPs for all sources. Let's define that. So we have the server and we want to pick all servers, and we need the IPv4 address. All right, same we need for the worker IPs. And then to get our internal IPs, we've used the iteration logic before based on the index count, and we will just use that here. And now we want to do the same for the work IPs. And the SSH user will be root environment configuration. And now we will proceed with the environment input variables for this module. Let's go into the env file. Here we want to expose the management protocols, the cloud infrastructure provider. Then we have the SSH public keys. You can define your SSH public key here. I will define mine. You can define additional keys. That's it for now. Let's continue with the first layer, and this will be the infrastructure layer. Here we'll define a Terragrunt.hcl file for the configuration of this layer. And here we want to include our global configuration, specifying the path to the root.hcl file here. For this we will use the find-in parent folders function, and this will find the root.hcl file and include it. Then we want to read our environment configuration, which we specified in the env.hcl file. For this we use the locals block and use the function read terragrunt config, and we will search for the env.hcl file. Okay, we have the global configuration included, we have the environment configuration included, which actually makes our code really dry. And now we can proceed. We want to source based on the cloud infrastructure provider variable the required module. So if we have the local.env-vars cloud infrastructure provider is Hetzner, then of course we will include the Hetzner infrastructure module. If not, we will just include a dummy module we will create now. So let's create the dummy module. since we want to keep things simple and work completely locally, and nobody else will execute our Terragrunt code within a pipeline, we can just stick with copy Terraform log file false. Then we want to define the inputs for the module, which was included here. And we want to merge the inputs with the local env-vars inputs, which we defined here, with the inputs we want eventually provide later. Okay. Now we need the Hetzner Cloud token and also the configuration of the server types and the worker types. I've already prepared my values for the configuration and will just use them. Actually, what this does is get the SSM parameter from the AWS cloud, which is stored under the name Hetzner token. It will decrypt the value and give me the text. And I will have one server node, one worker node, and the type of the worker and server node is the same. Then I define the first data center as the data center in Nuremberg in Germany. And the second data center is also located in Germany, in the city Falkenstein. And for the zone, I use EU Central. Now we can run our Terragrunt code and see whether it works or not. But before, I will create another helper script, and this script will destroy all the infrastructure. Destroy dev, and destroy dev will of course execute instead of run all apply, run all destroy. And also you have to configure the token yourself within this env variable. If you don't use the SSM parameter, you can just specify it here, but make sure not to commit the credentials. Testing and debugging. Okay, now let's check whether everything works and eventually fix the bugs. I'm now in the current repository of the K3S Cluster project, and the first error we get, no attribute named Cloud Infrastructure Provider. Okay, since we referenced the variables here and want the infrastructure provider, we have to go via the inputs. Okay, let's specify it here, inputs, and run it again. Okay, now we have an error in the merge named input is not expected here. Did you mean inputs? Yes. Retry. Do want to provision it. Okay. Now we have an error in the server internal IP section. It was already defined. Okay, let's look at that. Of course, this output should be named worker internal IPs, since we want the IP addresses of the worker nodes. And let's retry it. Initializing backend, okay. And we have a typo here, var, and we have copied the typo. Let's retry. And now we have the error here, invalid input in the field rules. Okay, we forgot the port here, and the port has the value any. Let's give the port. And now we can retry. Name is already used. Okay, we have a naming conflict here. And reapply. Okay, now the SSH key is not found. Let's fix that. The issue is that we directly providing the SSH public keys here, but we need to provide the keys we created in the cloud earlier. So let's do that. So hcloud SSH. Do the same for the worker nodes. And apply. Looks better. Worker and server nodes are getting provisioned. I'm going to provide the code in the GitHub repository so you can just use it. I think it's important to see the whole process of developing this code. It's not perfect at the first time. Okay, we have our server IPs here. Let's try to connect with root. And we are in. Okay, we have Rocky Linux running. Now we will destroy everything so we don't consume any resources. Okay, destroying completed. And you can see that we now have a state folder here, which contains our infrastructure state. And we also have the backup. And we have the Terragrunt cache. Recap of work done. Okay, let's look at the structure. We have created the environments. Within the environments, we have the environment-specific settings for the dev environment. And then we have an infrastructure layer with the layer-specific configuration. But this file references the env.hcl file and the root.hcl file. So we keep our code dry. Then we have the execution helper scripts. And we also have the modules, the Hetzner module and the empty module. Then we have the state directory. Make sure not to commit any state files in a Git repository if it's public, and try to persist the state since Terragrunt needs it to apply the changes. Then we have our Terragrunt cache, which we actually can ignore since it's just a copy of the module. But imagine if the module is in a registry, then Terragrunt would fetch the module from a registry, which is either in the internet or in your infrastructure. And that's where Terragrunt cache is required. Thank you for watching this video. Don't forget to like the video, subscribe to the channel and hit the bell button. See you in the next one.